Yes, Assalamu alaikum. I'm Elahi, and today we're going to start the lecture on work done by gravitational force or work done by gravitational field in chapter number 4. आज के लेक्चर में हम बात करेंगे वर्क डन बाय ग्रेविटेशनल फील्ड की। अगर एक बॉडी को हम ग्रेविटेशनल फील्ड में अगर एक जगह से दूसरी जगह पे हम उसे डिस्प्लेस करते हैं तो उसमें जो है वर्क डन वो कितना होगा। तो सबसे पहले वी डिफाइन द ग्रेविटेशनल फील्ड। दिस इज द स्पेस अराउंड द अर्थ इन विच इट्स ग्रेविटेशनल फोर्स एक्ट्स ऑन अ बॉडी इज कॉल्ड ग्रेविटेशनल फील्ड। मीन ज़मीन के गिर्द एक ऐसा फील्ड, एक ऐसा रीजन जिसमें कोई दूसरा बॉडी जो है वो ग्रेविटेशनल फोर्स जो है उस पर अमल करे या वो ग्रेविटेशनल फोर्स को एक्सपीरियंस करे, दैट्स कॉल्ड ग्रेविटेशनल फील्ड। नाउ टू फाइंड आउट द वर्क डन बाय ग्रेविटेशनल फील्ड, वी टेक पॉइंट ए, इनिशियली आवर बॉडी इज एट पॉइंट ए। देयर आर थ्री पाथ्स by which we can move from A to B. So path 1 is we move from A to D, then move from D to B. So finally we will reach from A to B. Path 2 is we will move first from A to C and then C to B. And the path 3 is we have irregular path from A to B. So there are three paths by following which we can move from point A to point B, and we want to calculate the work done in moving this body of mass m from this point A to point B within the gravitational field. So the height is h from the horizontal, or from the B, the vertical distance of point B from the x-axis or horizontal axis is h. In all three paths, if we see, the work done is by the gravitational field is up to the height of h. Whether we move from A to path 1 or path 2 or path 3, our height is h. So explanation में हम लिखेंगे, let's consider an object of mass m being displaced with constant velocity from point A to B along various paths in the presence of gravitational force as shown in the figure. In this case, the gravitational force is equal to the weight mg of the object, because the mass of the body is m, and within the gravitational field the force will be equal to the weight, because weight is also a force. So the force will be weight in this case, because we want to calculate the work done by gravitational field. So there will be, or there should be, the gravitational force, and the gravitational force is equal to the weight, and weight is mg, w is equal to mg, and it is always downward. The direction of the gravitational force by earth is downward. Okay, so the work done by path 1 will be equal to the work done from point A to D and D to B. So if we see for point A to D, because work is force is downward and the displacement is horizontal, the angle is of 90. So the work done will be 0 by the gravitational field or the gravitational force, because gravitational force is always downward, and we are moving from A to D, that is the horizontal distance. So the angle between the force and displacement is 90 degree. So that's why work done is 0 in moving from a body from A to point D. Next is from D to B, the distance covered is h and it is upward, but the force is downward. So the angle between the force and the displacement is 180. So cos of 180, we know that f is equal to w is equal to f d cos theta. So f is weight, d is h, and theta is 180. So the work done from by path 1 from A to D and D to B is equal to this one. Work A dB, this is 0 because A to D the work was 0, and this is minus mgh because weight was downward and we are moving from lower point to the higher point upward. So the total work done by path 1 is minus mgh. Similarly for path 2, the work done is divided into two components, and the one component is this one, A to C. The gravitational force mg is downward but the displacement is upward, so the angle is 180. So the work done will be minus mgh because the displacement is h. This is the height. But from C to B, our force is downward and the displacement is horizontal, so the angle is again 90. So the work done from C to B will also be 0. So the work done from A to C and C to B will also be equals to minus mgh plus 0. This is the result. This one. This is ACB path 2. So the work done along path 2 that is also equal to minus mgh. Now the third path, that is the curved path, irregular path, like in the stairs. If we are moving this one upward, then downward. But if we see, we have a small interval of displacements, delta y1, delta y2, delta y3, and this is the actually vertical component. If we divide the displacement, this displacement into two paths, two components, one will be along horizontal and one will be vertical. So all these vertical components, when we add, this will also again will be equals to the h. Like in the form of stairs, when we move upward, we are covering two displacements along x-axis and along y-axis, but the height of the stair is h. Similarly, like in this path, when we moving from A to B on this curved path or irregular path, our vertical distance covered is h. Okay, this is the point here. Similarly, the work done will be, because the force is downward and we are moving upward by by these small intervals, so the work will be minus mg delta y1 minus mg delta y2 minus mg delta y3 plus so on, so minus mg delta yn. So if we take common minus mg, so this expression we get delta y minus mg into delta y1 plus delta y2 plus so on. So, and also we know that when we add these vertical components, so all these add up and this is equal to the h, again height, this one. So the work done in along this path, this is also equal to minus mg h. So the net amount of work done along AB path is still minus mgh. So we can see from here easily that either we move from path 1 along path 2 or path 3, the work done is equal. The work done has the same magnitude and that is equal to minus mgh. So from here we may conclude that the work done in the gravitational field or the Earth's gravitational field is independent of the path followed. Whether we move, अगर हम पाथ ए से जाएं, पाथ बी से जाएं और पाथ 3 को हम फॉलो करें, तो हमारा जो वर्क डन है वो इंडिपेंडेंट ऑफ पाथ है, वो इक्वल है, उसकी मैग्नीट्यूड हमारे पास माइनस mgh आ रही है. तो इसका मतलब ग्रेविटेशनल फील्ड में अगर हम कोई भी रास्ता अपनाएं किसी दो पॉइंट के दरमियान, तो उसमें जो वर्क डन होगा उसकी मैग्नीट्यूड होगी वो सेम होगी. नेक्स्ट इज द कंजर्वेटिव फील्ड, और ऐसी फील्ड जिसमें वर्क डन इंडिपेंडेंट ऑफ पाथ हो, जिस तरह का भी हमने साबित किया है ग्रेविटेशनल फील्ड में, अगर हम पाथ 1 को फॉलो करें, पाथ 2 को फॉलो करें या पाथ 3 को फॉलो करें, हमारा वर्क डन सेम है. तो द फील्ड इन विच द वर्क डन is independent of the path followed or the work done is in a closed path is zero is called conservative field. एक ऐसी फील्ड जिसमें वर्क डन जो है वो इंडिपेंडेंट ऑफ पाथ फॉलोड हो, उसे हम क्या कहते हैं, कंजर्वेटिव फील्ड. एंड ग्रेविटेशनल फील्ड इज वन ऑफ द एग्जांपल ऑफ कंजर्वेटिव फील्ड. So this is a long question, and if you have any query or any question about this, you are most welcome. Thank you very much.